Hey everyone. Oh, yep. Looks like it is recording now.
Perfect. Thank you.
Okay, I think we can get started. Or do we want to wait a bit more, or we can get started?
You can wait maybe a minute.
Okay.
Is there a reminder in the Slack channel?
Yeah, and
In which,
minutes ago I sent in the on llm-d.
No, but not on CGK disaggregation.
no, but in all, I think it's always in all.
I put in on.
You put, but it's not automatically. I will.
No, it's not.
We should have also automatic reminder.
Yeah, there actually should be an automatic reminder, and I'm actually not sure why it didn't fire. I'm just looking at that configuration now. So, but yeah, we'll get an
Okay.
automatic reminder like we have for the others, just so everyone can know when it does get started.
Okay, I think
Thank you.
we can get started now.
Okay, so this is our first call in the SIG KV disaggregation. I'm sharing the agenda, and you're all welcome to still propose items while it's running if we get to them. We'll start with introductions, then get into the general scoping and vision in this SIG. And then we'll have time for open forum and overview of the ongoing work streams. So let's start with introductions. I'll start. I'm Maroon. I co-lead this SIG with Danny, and I'm a maintainer of the llm-d KV cache manager. We can go in order. Burak, feel free to defer by that.
Hello, I am Greg. So I'm actually trying to contribute to llm-d, and in my company, I'm looking for integration of llm-d into our clusters. So happy to be here, and I hope I can provide much more input to the community. And thanks, Maroon, and I will forward to Neely.
Okay, let's use the order as it appears here. Some of the people here you already know, but we'll go anyway. Abdullah.
Yeah, I'm Abdullah. I work for GKE, mostly focused on Kubernetes open source and specifically inference, making Kubernetes great for inference workloads.
Song.
Yeah.
Sorry. Continue.
Song?
Song.
Hey, my name is Tong. I work for Google. I implemented the Gateway API extension prefix cache plugin, and I'm working very closely with Maron and Cooper on optimizing the prefix cache. And internally, I'm also working with Google teams on implementing tiered cache with Google specific backends.
Daniel Henry. Daniel Henry, do you want to introduce yourself? Okay. Danny.
Yeah, hi, I'm Danny. Like Maroon said, I'm co-leading this SIG with him. I work for IBM Research, working on KV cache, offloading, storage, etc.
Guy Margalit. You just joined, so we're doing a round of introductions, and your name came right after Danny.
He may be still connecting, Maron, so let's go
Yeah,
to
well, let's jump to Kellen.
Hello, hello. I'm with Google as well. I've been working on Inference Gateway. Excited to contribute here and learn what y'all are up to. Mostly working on inference as well.
Kfir?
Hello, my name is Kfir. I'm working in the inference scheduler, also focusing on the KV cache and the prefix with Song and Maroon. That's it.
Michal?
Hi, my name is Michal. I'm from IBM Research. Working with the team here on KV cache and some also other aspect and leading some of the people here.
Mishi?
Yeah, hi, I'm Mishi Mehta. I work on performance of llm-d at Red Hat.
Neely?
Hi, from IBM Research, working on the inference scheduler, PD disaggregation, also KV cache.
Or?
Hi, I'm Or. I'm from IBM Research, working with Danny also.
Pete?
Hey everyone, I'm Pete. I'm with Red Hat's Open Source Program Office, and I'm here to provide community support and architecture for just the llm-d community. So if anyone needs any help with anything as simple as meeting recordings or anything community related, definitely reach out to us on the community channel on Slack.
And Vita?
Hi, Vita, IBM Research, sort of overviewing all the activities and scheduler and KV cache that we are doing.
Okay, I'll jump back to G since there are only two. Guy Margalit.
Everyone, my name is Guy. I'm from IBM Storage, working on IBM Scale Storage and in connecting to KV cache and the likes. So nice to meet you.
Good to have you.
And Guy Germansky, fine.
Hey all, I'm also Guy from IBM Research, and I'm working on the KV Cache Manager.
Okay, one last member just joined, Yang Lee. Feel free to introduce yourself.
Oh, hi, this is Yang. I'm from Google. I work in the same team as Tom and Abdullah. So, yeah, that's the intro. I'm still learning about the topics, and I'm studying the VLLM and looking forward to contribute.
Happy to have you. Okay, so with that, I'll move to the high-level overview or scoping of the SIG. It won't be a deep dive. You can find the deep dive in the open docs, and there is an ongoing rewrite of the prefix cache North Star, which will be out later at some point. But in high level, the scope of the SIG is enabling KV cache-centric inference, which means intelligent KV cache management to improve inference performance. That contains KV cache offloading for KV cache reuse, whether across one node or one VLM engine or multiple, KV cache indexing for smart decision making, KV cache sharing, which is interconnected with reuse. And I'll elaborate on each of these points that you see on the screen, but it won't be a deep dive. So to get deeper into the different domains in the SIG, we have simple VLM native north-south offloading. North-south means vertical offloading across a single or individual VLM engine, that such as offloading from GPU memory to CPU memory. And the goal here, or the idea behind simple and VLM native, is to have this capability without any dependency on an external engine, to have it simple and easy to use natively in VLM. The second point, global VLM native KV cache indexing. Again, VLM native, independent of any external engine, but does support external engines. A central or a distributed global index of KV cache localities and informations to enable AI-aware routing, such as accurate KV cache aware routing to maximize KV cache hits. And it would also be utilized by the east-west domain. East-west means once you step out of the single VLM engine, for example, to reuse or share KV tensors, then you step into the east-west domain. I'll get into it in the last point. Then there is pluggable local or shared storage. On this point, Danny, feel free to expand, but I want to highlight the keyword pluggable here. So if you need it, you can have it. If you don't, you don't have to take it. And that's a very important concept we want to push. So you don't have to get all the features or a monolith of features to get if you need just a portion. Danny, do you want to add something here? If you're talking, you're muted.
Okay, and not much. On storage, I want to just say that there is quite a difference in complexity between local storage and shared storage. Shared storage will give you sharing kind of for free, but both are, as you said, pluggable. We want to be able to, in the end, to support both, but just in terms of staging, probably not all at once. And just to comment that pluggable, I think, is true for more or less every item on the list, not just the storage and share.
Sure. Yeah, that's a good point. We have a question, Abdullah.
Yeah, we're wondering if we're going to cover guiding principles and when to fall back, for example, when using remote, it makes sense. I would assume that we can do a lot of calculations here based on pre-fill rates that we get for specific models, how fast we can use caches from memory versus local disk versus remote disk.
Yes,
Yeah, just wondering if there's some framework that we can build as well here for that.
I would say that's a cross-SIG effort. That's definitely something we're looking at. In the end, you want the users to know what they should have or what fits their workloads. So that's definitely something in scope, but I would say it's a cross-SIG item. I wanted to discuss it when we go to the open work streams, but this is definitely something we're looking at with benchmarking folks. There's also the work, I think Song will want to talk about that, on improving the KV cache or prefix cache aware plugin to be tunable this way, and will also provide the data needed for users to know how to tune it.
Song.
Yeah, I want to echo Abdullah. I think this is definitely an important topic to discuss. I want to share that I am, if anyone is thinking about same lines, I would like to collaborate. I am kind of working on some basic sort of a calculator and a use case driven calculator based on some different use cases and the characteristics of your workload. I try to kind of present a calculate, for example, how many CPU host RAM KV cache you need, and how many maybe remote cache you need. Just give you some guiding kind of design on the pluggability, the pluggable pieces, and what to choose and when you need it and how much do you need. If someone is working on this, I'll be very happy to collaborate. I hope I'll share something like a basic kind of spreadsheet style that just highlights the key points to consider when designing a KV cache system.
That would be very interesting to see. We can definitely follow up offline on that. Vita.
So first, I think yes, Song. Let's follow up on that. I think that Abdullah about design principle and maybe something to say. So today, The current implementation is dependent on LLM cache. What we are doing now with the part that Maroon is presenting is given a basic capabilities with what we call fast. I think it's something that definitely brings value, the CPU memory extension and the native indexing without LM cache. And I think after that, there is all this sort of calculations, pluggability. So I think we are about to put some sort of a framework or, a document that will put all together different parts, but there is a core. What Maroon discussed now, we see as something that is a basic that will come as a default, will be simple and will be extensible with the different, sharing to shared storage, to local storage. And then I think, Son, also all the calculation parts will be very important.
Thanks. A quick follow-up on the LLM cache part. Are you saying that we are going with a path that does not depend on LLM cache? I hope the doc will clarify, what LLM cache provides or what's the limitation.
Absolutely. So current implementation of llm-d, because of was the initial one, and it is LLM cache dependent. But what we are working now and what Maroon is sharing is independent of cache. LM cache will be pluggable as yet another backend to this solution.
Yeah. So that should be covered in the North Star and the open docs. In the global indexing doc, I did refer to the integration with or the support of LM cache, but the idea is really to streamline a VLM native version of all the required features and support in external integrations, such as LM cache. I want to cover the last item in the scoping, which is pluggable east-west sharing. We went over what this means, and in this domain we see two categories, one being reactive sharing to support KV cache reuse across different VLM engines. So think, for example, you have a very loaded VLM engine pod that has long and tons of KV prefixes, and you want to migrate, or your router now decides to serve the same session or same user on a different pod for load reasons or because it's unavailable or whatever. So in that case, it would be useful to reuse the KVs to fetch them remotely and reuse them. But this should be supported by data and use cases, of course. The second category is proactive east-west sharing. This path, so this is sharing on a non-critical path for optimizations such as duplicating or migrating hot caches or hot KVs, preparing for a scale down or scale up, and things like that. These should be covered in the prefix cache North Star and the open docs. I think we already started the open forum, but feel free to raise any points or if you have any other questions. If not, then I think we can move to the open work streams. So we'll cover open items in this SIG and across the different SIGs or the SIGs that we have interactions with. Starting with our own SIG, we have two major work streams going on. The first is mostly on VLM or contributions to VLM, which is the implementation of the north-south KV cache offloading in VLM. Or is managing that effort. There is an open RFC in VLM. There are already a few PRs open for review, and there are several more to come. Or do you want to add on that?
Yeah, so a bit what I said that we had a design document in llm-d, and then I opened up an RFC, which based on this design document, and already got some got some feedback from Nikhil from the DLLM community. And in parallel, working on the actual PRs, so a couple of them already out, and waiting for a community review and continuing for other PRs.
Thank you all. So to summarize, this work would enable GPU to CPU offloading in VLM independent of an external engine. It would also reuse the existing KV events API that was contributed by Dynamo to publish KV events from the CPU cache through this implementation. Danny?
Yeah, I wanted to point out one topic that came up in this area is today all the offloading via connectors is done automatically, meaning that everything is offloaded. It's not a swap in, swap out from GPU. So the initial design and the simple design is just everything that's generated, every KV tensor that's generated, just spill it out from GPU to CPU, and then you can enlarge this. The problem is this works very well if CPU memory is much larger or generally at least significantly larger than the GPU memory. If they're on the same order, then basically you're duplicating GPU and CPU memory and you're not gaining much, in which case we'd rather do a swap in, swap out. I think one of the feedbacks we want to hear is how much any of the environments you feel there's a disparity between. If CPU memory is much larger, there's a much simpler implementation. If CPU and GPU are kind of on the same order, then the implementation is a bit more complex. If you have any feedback on that, we'd be happy to hear.
On GCP, the GPU machines, generally the CPU memory is like 3x of the GPU memory.
Okay, and that's a good point. I'd say this is kind of in the range where it starts to say, okay, if it's 3x the GPU memory, basically you can go from, okay, we have 3x the space, or we can actually shoot for 3.7, close to 4x the space. Of course, when we're talking about GPU memory and CPU memory, you have to count only the part that's allocated for KV cache. So we're not talking about what's used by the model itself. So that's also a kind of if you have a kind of more exact numbers that would be interested in hearing.
Yeah, so as a part of the calculator, I'm considering this. So you minus the model weight. So generally, your CPU memory will be more than 3x of what's available for KV. I'm curious to know in this IFC that is this host RAM implemented as a kind of a superset of the HBM cache or separately, meaning that if you have a KV cache into in HBM, it will also for sure be kind of replicated in CPU, but because CPU RAM is larger, so you get more, or they are separate cache indexes.
So I think the answer here is we can make it a superset, which is simpler to implement. It also works well with the offloading. If you're thinking forward about offloading to storage, for example, then everything is offloaded to CPU, and from there you can offload it further down the line. But if say the GPU and CPU memory are on the same order, just to give the extreme case, then just replicating it buys you nothing. So in that case, we'd want it to be mutually exclusive or almost mutually exclusive. So whatever is in GPU doesn't have to be in CPU. So those two models to implement this, and we're looking at both basically.
Yeah, to add on the trade-offs, so in more advanced deployments where you have DP, mixture of experts on high scale or high scale of deployments and high scale of load, you might get congestion on the GPU RAM because there are multiple components in each of these work streams that will fight for these resources. But it's definitely a matter of getting more information on usual or general deployments. So feel free to contribute to the RFC. I think the discussion was started there. It was started by Nick on this point. It would be helpful to get this information here and on the RFC directly. So the second work stream or ongoing work stream in this SIG is the implementation of the KV cache indexing or VLM native KV cache indexing with KV events. The status of that work is, so there is this doc and also the doc for North-South implementation that tracks the design. It has been reviewed. There are discussions there. Feel free to review and comment. It's being implemented. The majority of the restructuring and the implementation of the missing pieces is done and merged in the repo. And there is ongoing final PR, which is not open yet, to actually make the connection with VLM. So once this work or the third PR is complete, we would have VLM native KV events based GPU KV cache indexing, which is independent of any external engine, such as LM cache. And there are several open issues in the KV cache manager repo. We have been, Borak here, I think he contributed. We have some more good first issues. Feel free to contribute there. Okay, so now to the interactions or the cross SIG work. There is the prefix cache aware scorer plugin proposal, which, like Song said, is so Song is heavily involved with that, and Kfir is too, which targets the unification of the GIE and the llm-d's prefix cache aware scorer, which is based on routing history estimations or estimations of KV cache localities based on routing history, and the llm-d KV cache aware scorer, which has been using LM caches indexing, and once the previous work is complete, would use VLM native indexing. So we proposed unifying them for easier UX or more intuitive UX, and that work stream is ongoing. Here is implementing that. And finally, with the benchmarking SIG, we had initial talks on getting started with benchmarking workloads that would give insights on when it is useful to use KV events, when estimations can be used, and such. And this is relevant to your point at the beginning of the call. So with that, we covered all items. We can move to questions with the 1 minute left. Abdullah?
Just about we're talking about like releases in general. It would be nice to start, for example, having some sort of I don't know, target dates aligned with the releases that we are planning for llm-d and Inference Gateway. For example, Inference Gateway, there is a planned release in mid-July for 0.5. I don't know if we want, for example, the prefix cache aware scorer to make it to that release would be really nice if we make it just in terms of planning.
Good points. We should definitely address these. We have an open roadmap, but it should be revisited. Neely?
Yeah, I agree with Abdullah. I think that there are two main items that should be in. One is the yeah, I think the two should be there. The KV indexing that is basically only based on KV events, and the convergence of the two scores to be tunable. So these two should be in their next release.
Sounds good. Yeah. Kellen is planning to draft a release
Yeah.
plan for 0.5, and then we can tag you in there so that we can align what we want to have in 0.5.
Yep.
Sounds good. Okay, so we are out of time. Thank you all, and we'll see you next week.
See you on Slack, and there's a lot. All links are there, as well as on the agenda of the meeting. So your comments and input is welcome.
Thank you.
Thank
Thank
you.
you. Bye bye.
Bye.